the number of units X that consumers are willing to purchase at a given price is called the demand function. So imagine I'm selling shirts. If I sell shirts for $10, there's going to be a certain demand, versus if I sell those shirts for $100, there's going to be a different demand. So demand, which is going to be the quantity that you end up selling, right, depends on the price. That's called the price demand function. So how do you find revenue? Imagine I'm selling shirts. Well, if I sell those shirts for $10 each, I might sell 100 shirts. So to find my revenue, I would do 100 times 10. And again, if I change the price, if I change those shirts to $100, maybe I'd only sell 5 of the shirts. So my revenue would be 5 times 100. So revenue is always price times quantity. The revenue is always price times the quantity. The price is P, the quantity in this case is X. Of course, multiplication doesn't matter which order you do it in, it's commutative. So they say X times P, I say P times X, it does not matter. So let's look at this. It says find the revenue function and marginal revenue for the demand of P equals 2,000 minus 4X. Find the marginal revenue when X equals 250. So the one thing that I want you to notice here is we have two P's when we're dealing with business functions. There's a capital P. The capital letter P stands for profit. Capital R is revenue. Capital C is cost. The lowercase p here is the price demand function. And if you notice, if you think about plugging in numbers into this price demand function, which is 2,000 minus 4x, the higher the price, the lower the demand here, okay? So that's really what's going on here. So it says, find the revenue function and marginal revenue for a demand function of P equals 2,000 minus 4x. Find the marginal revenue when X equals 250. So the first thing we want to do is find the revenue function. The revenue is the price times the quantity. In this case, that would be X times the price demand function, which is 2,000 minus 4x. I want to go ahead and distribute this, so I'm going to distribute the x through to both terms. I'm also going to write it in descending order, just because that's how the proper way to write things. So my revenue function would be negative 4x squared plus 2,000x. That's my revenue function. Negative 4x squared plus 2,000x. Again, I just changed the order of those because addition is also commutative. So that's my revenue function. It says find the revenue function. Boom, I'm done. I found that. And it wants me to find the marginal revenue. Marginal revenue would be the derivative of that function. The derivative of negative 4x squared would be negative 4 times the derivative of x squared, which is 2x, plus 2,000, the coefficient, times the derivative of x, which is just 1. So my marginal revenue function would be negative 8x plus 2,000. We've now found the marginal revenue. And then it says find the marginal revenue at 250 units. So all we have to do now is plug in the 250 units at x equals 250. So my marginal revenue would be r prime of 250, which would be negative 8 times 250 plus 2,000. What's negative 8 times 250 plus 2,000? Well, that is 0. So what the heck does that mean? 0, well, let's think about the units. What's revenue? Revenue is in terms of dollars. So change in revenue, the derivative of that would be dr dx, which is change in revenue, which is dollars, and dx would be the number of units. So what does that mean? This would be dollars per unit. So what does that mean? It means my revenue is not changing from the 250th unit to the 256th unit. How could that happen? How could my revenue not change from the 250th unit, sorry, not 256, 251st, from the 250th unit to the 251st unit? Well, again, this revenue function depends on what's the price. Well, if the price is too high, I'm not going to sell any more units. So that's what this is getting at here. What's my marginal revenue? It's not expected to change. So if I sell 250 units or I sell 251 units, my actual revenue does not change.